Hello everyone, thank you and welcome back to the good stuff that we have been doing. And today we're going to look at this scary integral and quite intimidating, to be honest. And the most attractive thing about this integral is a beautiful closed form, which is 2 pi log phi, where phi is the golden ratio and pi over square root of 2 logarithm of 2 plus square root of 3. And notice that this logarithm of 2 plus square root of 3, you could write it as logarithm of tan of pi over 12, which is why this integral is so beautiful. Now, looking at this integral, you tend to feel like that nothing can be done here, but there are things here. First of all, we have a complicated argument, and now this may look somehow difficult, but the complicated argument is actually what makes this problem simple, because if you have complication, then the next thing you need to simplify, and that means you have a path. On the other hand, if it was simple, it would be difficult to even know what to do. But here, since it's complicated, then we are happy to dive into it. Now, obviously, everything will revolve around this argument of this tan inverse. So let's donate it by theta of x, which is 2 sine of x, all divided by 2 cosine of x minus 1. And notice that tan inverse of tan of x would be equal to x, of course, if x is in negative pi over 2 less than 0 less than pi over 2. If x is within this range, of course, tan inverse of tan x will be x. But if x is not within this range, then it will be x minus pi. But that tells us that if we could express this in terms of tan, then tan inverse of tan would equal something. So it is possible to actually simplify the argument of this inverse tangent. I mean, if it is possible, then the problem can be easily solved. Okay, so let's begin by trying to put everything in terms of tan, whereby we're going to use the double angle formula, and we're going to get 2 multiplied by 2 sine of x over 2, okay, times cosine of x over 2. Okay, times cosine of x over 2. Then at the bottom you have a 2. Then you have a cosine squared of x over 2 minus sine squared of x over 2, then minus 1. And if you proceed in this fashion, you would have on this side, let's divide both top and bottom by cosine squared of x. So you have a 4 times tan of x over 2, and then at the bottom you have a 2 minus 2 tan squared of x over 2 minus secant squared of x over 2. Of course, we don't even need to think. The next thing is to express secant squared in terms of tangent, so which gives us 4 tan of x over 2, all divided by, okay, then you have a 2 minus 2 tan squared of x over 2, because secant squared is 1 plus tan squared. So you have first of all, you have a 1, and then you have a minus tan squared x over 2. So this leaves us with 4 tan of x over 2, all divided by 1 minus 3 tan squared of x over 2. Now, check something out now. Now, this may look heartbreaking because everything is not in terms of simple tangent. But if you recall the addition formula for tangent, it says that tan of a plus b actually equal tan of a and plus tan of b, all divided by 1 minus tan of a tan of b. So now you may not see the connection yet, but what if we write this as just tan of x over 2, and then we write this as plus 3 tan of x over 2, okay, all divided by, then you have a 1 minus 3 tan of x over 2, and then you have a just, let's not confuse you, but let's just write this as just tan of x over 2. Then you have a 3 tan of x over 2. So this right here, which looked very okay. Now this expression right here, okay, let's keep this side. This expression like right here looked very confusing. Now look at it in this form now. They are quite the same thing though, but this one is much more illuminating because we could say, okay, this may actually be equal to, first of all, the tangent of, say, x over 2, okay? Because now, at the first part, you have a x over 2. Then what about this part? Well, this will be plus tan inverse of 3 tan of x over 2, of course. Yeah. This will be that. Now, you may not believe me, but check it out. If you use the property of addition theorem, you will have, first of all, tan of x over 2. Then secondly, you will have a tan. Now, tan of tan inverse would cancel out. So you have a 3 tan of x over 2. Okay. And then you have a 1 minus 3 tan squared of x over 2. So you see that our theta of x has been simplified greatly, like so much. Now we can write theta of x to equal tan of what? X over 2 plus tan inverse of 3 tan of what? X over 2, which is a whole lot of progress because everything now is in terms of tan. Okay, now let's go back to our original integral. Now let's quote our original integral. Then the integral we intended to solve was the integral from 0 to pi over 2 of the tan inverse of theta of x. Okay, then you have a sine of x over 2 divided by square root of cosine of x dx. Okay, this is the integral we intend to solve. Now we have simplified theta of x, although there is one big problem now. We can't just say this is equal to the integral from 0 to pi over 2 of x over 2 plus tan inverse of 3 tan of x over 2. We can't just do this and then write sine x over 2 divided by square root of cosine of x dx. The reason we can't actually get away with this if we try is because, first of all, to begin with, we don't know if this entire argument, we don't have any way of knowing if this entire argument is less than pi over 2 for x. Okay, we don't have any knowledge because it is only when this entire argument is less than pi over 2 do we have tan inverse of tan x equals to x. Okay, now we need to check if this entire argument is less than pi over 2. Then, first of all, to begin with, let's check the boundary terms. Let's start with theta of x. Okay. Let's start with theta of x, which is tan of. Okay, let's start with the inner expression, not even theta of x. Let's start with the inner expression and see. Let's start with, say, x over 2 plus tan inverse of 3 tan of x over 2. Now let's set x to be 0. At the boundary term, you have a 0 plus tan inverse of 0. So you have a tan inverse of 0, which is 0, right? So you have a 0. So that is less than pi over 2. So that checks. What about the extreme end? So x equals to pi over 2. Then you have on this part, you have a pi over 4. Then this part right here, you have a tan inverse of 3 tan of pi over 4. So you have a pi over 4 plus tan inverse of 3. So let's check calculator and see. Let's check and see. Where is this? No, sorry, I should have kept this ready. So you have a pi over 4. So pi divided by 4. And then you have to add arctan. So this is the arctan function. Tan inverse of 3. Okay. I'll put everything in radian. So you have a 2 point. So everything here is 2.03. So everything here is approximately 2.03. And then what about the case of the pi over 2? Pi over 2 on the other hand is pi over 2 is actually 1.5. Pi over 2 is approximately 1.57. So you see that this argument is bigger than pi over 2 at some point, because at some point when x was 0, it was less than pi over 2. Now x being bigger than 0, at some point it became bigger than pi over 2. Now the task here now is to look for that point where it became bigger than pi over 2. So what we'll do is that, first off, we're going to just we're going to try to find where it is equal to pi over 2. Okay, let's find that point where it is equal to pi over 2. So let's set pi over 2 to equal x over 2 plus tan inverse of 3 tan of x over 2. Now we're going to solve for x here. Okay, so this means that tan inverse of 3 tan of x over 2 would be equals to pi over 2 minus x over 2, or tan inverse of 3 tan of x over 2 is equals to tan of pi over 2 minus x over 2. So which means that 3 tan of x over 2 is pi over 2 minus x over 2. So no, pi over 2 is cotangent of x over 2 rather. Yeah, is cotangent of x over 2. Now that means 3 tan squared of x over 2 would be equal to 1. Yes, so therefore that means tan of x over 2 would be 1 over square root 3, and 1 over square root 3, what's tangent? What is tan? So x over 2, first of all, x over 2 would be tan inverse of 1 over square root of 3, which is going to be like, how do you get square root of 3? I think you do 1 over 2 divided by square root of 3 over 2. So that is pi over 6. So x over 2 would be equal to pi over 6, which means that x is equals to pi over 3. Yeah, only at x equals to pi over 3 do we actually have equality. So basically that means that as x is bigger than pi over 3, this theta of x actually would be equal to pi minus theta of x. So the tan of theta of x would be pi minus theta of x. But if x is less than pi over 3, then tan inverse of theta of x would actually be equal to just x. So now we have everything ready. So this is our integral before. Yeah, this is our integral now. We are going to split it into 2 parts. Okay, so the integral, let's cut it again. Okay, the integral from 0 to pi over 2, which is tan inverse of theta of x, okay, and times sine of x over 2 divided by square root of cosine of x. So this right here would equal, first half, the integral from 0 to pi over 3 plus the integral from pi over 3 to pi over 2 of what? Tan inverse of theta of x times what? Sine of, oh, I didn't forget the x, sine of x over 2, all divided by square root of cosine of x dx. Now that means we're going to separate the integral into 2 parts. So the first part, you would have 0 to pi over 3 of what? Tan of x over 2, yes, of x over 2 plus tan inverse of 3 tan of x over 2. Then you will have sine of x over 2 all divided by square root of cosine of x dx. Then you have a plus the integral from pi over 3 to pi over 2 of what? Then you have a pi minus, right? Yeah, you have a pi minus. Yeah, pi minus x. So you have a pi minus x over 2 times what? Times the plus tan inverse of 3 tan of x over 2. Then you would have sine of x over 2 divided by square root of cosine of x dx. So now we can actually combine these two integrals together. Notice that the integral, notice that first of all, if you consider this integral and the last integral, just without the pi, just let's say on this other part, the integral from 0 to pi over 3 minus the integral from pi over 3 to pi over 2 should, because if you consider the integral from 0 to pi over 2, this is equal to the integral to 0 to pi over 3 plus the integral from pi over 3 to pi over 2. Okay. Okay, or better still, there is a bit of mistake here. Yeah. Because where tan inverse of tan x, tan inverse of tan x actually is equals to x minus pi, not the pi minus x. If x is bigger than pi over 2, then it's equal to x minus pi. So we should have a plus sign here and a minus sign here. So basically, when we combine the integral from 0 to pi over 3 plus the integral from pi over 3 to pi over 2, we should get the integral from 0 to pi over 2. So next up, this everything right here would become the integral from 0 to pi over 2 times what? X over 2 times plus tan inverse of 3 tan of x over 2 all divided by sine of x over 2 divided by square root of cosine of x dx. Then the second integral that is multiplied by pi would be pi times integral from pi over 3 to pi over 2 of what? Sine of x over 2 divided by square root of cosine of x. I have solved this integral on my page before, so I'll leave it to the reader to either search for it or solve it. But I've solved it several times, so but it's easy. Just take t to be square root of cosine of x and everything will be fine. This is not our problem. So first of all, everything is now reduced to just solving this integral, which is, let's call it k, which is integral from 0 to pi over 2. Then you have an x over 2 plus tan inverse of what? 3 tan of what? X over 2. Then sine of x over 2 divided by square root of cosine of x dx. Now, next up now, how do we handle this? Even though we have done the hard part, it remains to be seen how we can take advantage of this substitution we have made now. Of course, the problem has been simplified considerably, but it's not all work is not done yet. So what we're going to do is that we're going to still write this as, check it out, we're going to write it as 0 to pi over 2 of what? Tan inverse of tan of x over 2, okay, yeah, plus tan inverse of 3 tan of x over 2, okay, then sine of x over 2 divided by square root of cosine of x dx. All right, so why do this? Well, it becomes clear because notice that this is going to be 0 to pi over 2 of what? First of all, write the integral from 0 to 1 of x over 2 of tan of x over 2 all divided by 1 plus t squared tan squared of x over 2 plus integral from 0 to 3 of what? Tan of x over 2 all divided by 1 plus t squared tan squared of x over 2, and then everything is divided by, here is dt, and everything is multiplied by sine of x over 2 divided by square root of cosine of x dx. Now you may be confused, why bring up another complication? Well, like I tell you, we thrive in complications. You must learn how to accept complications if you do math, and this formula is obviously the formula that the integral from 0 to the tan inverse of x rather is equal to integral from 0 to 1 of x over 1 plus xt s squared t squared dt, and also tan inverse of ax equal the integral from 0 to a of x over 1 plus x squared t squared dt. So I use the first formula for this and the second formula for this. So take your time and digest these formulas. So now we can proceed and write this as what? The integral from, so we can switch order of integration now and just write this as the integral from 0 to 1 plus the integral from 0 to 3. Okay, then we are going to try to integrate the integral from 0 to pi over 2 of what? Just tan x over 2. Okay, then 1 plus t squared tan squared x over 2 dt, then all divided by well, everything is being multiplied by sine of x over 2 times square root of cosine of x dx, then dt. So what we are doing now is that we are trying to first of all do the integration with respect to x, keeping t as a constant, and then after which we are going to do the integration with respect to t. Then whatever we get, we just add it to the value we got with our integral, and then we are done. So how do we handle this part? You have, first of all, the integral we're going to focus on is integral from 0 to, let's call it j, is the integral from 0 to pi over 2 of what? Sine squared of x over 2 divided by square root of cosine of x, all divided by 1 plus t squared tan squared of x over 2 dx. Now t is basically treated as a constant, so let's take u to be square root of cosine of x. Then you would have u squared to be cosine of x, which means that 2 times u du is sine of x, negative sine of x dx. And notice that when u is 0, cosine of x is 1, and when u is 1, cosine of x is 0. But because of the negative, the integral will still remain would still be from 0 to 1. So this integral will be from 0 to 1. Okay, then on this part here, let's simplify things now. Sine squared of x over 2, how do we, okay, wait, we have an extra cosine of x over 2 here. We should have an extra cosine of x over 2 here. Yeah, let's go up and see, because I think here we converted the tan. Let's see. Here we converted the tan to sine of x over 2. So sine of x over 2 multiply sine of x over 2, you get sine squared x over 2, but the extra factor of cosine squared of x over 2 is at the bottom. So we have So we have to, first of all, what is cosine of x over 2? Because we know that cosine of x, twice cosine of x over 2 is equals to 1 plus cosine of x. So which means that cosine of x over 2 would be square root of 1 plus cosine of x all divided by 2, which will be square root of cosine of x being u squared, which is 1 plus u squared all divided by 2, which is 1 over square root of 2 times square root of 1 plus u squared. Okay, now what we have done for cosine of x over 2, what about sine squared x over 2? Well, sine of x over 2 has similar formula, I think. Twice sine of x over 2 is 1 minus cosine of x. So essentially sine of x over 2, okay, it's twice sine squared. So sine squared of x over 2 is going to be 1 over 2 1 minus cosine of x, which is u squared rather. Okay, now what about square root of cosine of x? Okay, that one is basically the u. What about the bottom part, tan squared of x over 2? Well, that one is the complicated part, and that one we have to do it carefully, because you're going to write it as 1 plus t squared, then you would have sine squared of x over 2 divided by cosine squared of x over 2, and that would be 1 plus t squared. At the very top, sine squared of x over 2 is going to be half of what? 1 minus e squared. Why the cosine squared of x over 2 is going to be half of what? I think 1 plus t squared, 1 plus e squared. Half of what? Yeah, 1 plus, we're going to be half of 1 plus u squared, yeah. 1 plus u squared. So which is going to be, the half cancel out, you would have 1 over 1 plus u squared times 1 plus u squared plus t squared 1 minus u squared. Yeah, so this is how the bottom is going to simplify to. Now what about let's see, dx. Okay, we have already done dx, so now we can plug everything back here. I think we still have some space left, and then you would have the integral from 0 to 1 of, first of, at the top, the numerator, we have simplified it to be just where did you simplify the numerator? Okay, we didn't simplify the numerator. The numerator is just sine squared x over 2 divided by cosine of x over 2 all divided by square root of cosine of x, which is sine squared x over 2 is just half of 1 minus t squared. Then cosine squared of x over 2, cosine of x over 2 is just 1 over square root of 2 times what? Times square root of 1 plus t squared. Yeah, so times u, yeah. This is u squared, yeah, u squared. So times u, and then let's see, this is getting so long, but okay. So we have the integral from 0 to 1. At the very top, you will have a square root of 2 over 2, square root of 2 divided by 2. Then you would have you would have times 1 minus u squared all divided by square root of 1 plus u squared times 1 over u, and at the very bottom you have a 1 over 1 plus t squared, 1 plus u squared times 1 plus u squared minus plus t squared 1 minus u squared, then dt is okay, we're not even done with dx. That is the worst part. We're literally not even done with dx, because here, even if let's say negative sin of x dx, sin of x dx is basically negative square root of 1 plus 1 minus cosine squared x dx. So cosine squared x is t to the fourth, so that would be negative square root of 1 minus t to the fourth. So at the bottom here you have a 2u times negative or 1 over square root of 1 over square root of 1 minus u to the fourth du. So this square root of u to the fourth now, we can cancel it. We could see that we could write 1 minus u to the fourth to be 1 minus u squared times 1 plus u squared at the bottom part here. Then we can separate it into two square roots. Then on the other hand here we have a square root of 1 plus u squared, so they multiply out to get a 1 plus u squared. Okay, so basically you will have something like this, square root of 2 times integral from 0 to 1 of what? So you have 2 square root of 2 rather, so you have a 1 minus u squared all divided by 1 plus u squared times 1 plus u squared plus t squared 1 minus u squared. Then here you would have, since the square root is coming to the bottom, you have 1 over square root of 1 plus u squared times 1 over square root of 1 plus u squared times 1 over square root of 1 minus u squared. So this and this, they become a, okay, this is 1 over rather, so they become a 1 over 1 plus u squared, and they cancel out with this. So with this, so you would have on this top, you have a 2 square root of 2 times integral from 0 to 1 of 1 minus u squared divided by square root of 1 minus u squared, all divided by 1 plus u squared plus t squared 1 minus u squared. Then you have du. So okay, and then this would be just square root, so this would be 2 square root of 2 times integral from 0 to 1 of square root of 1 minus u squared, all divided by 1 plus u squared plus t squared 1 minus u squared du. So now we have simplified this expression here. So here we have simplified this expression here, coming from this part here. Yeah, this integral is crazy long, but it is what it is. And I decided to I didn't just say, okay, let me just write down the answer and just give it to you and just know. I wanted to see the pain of solving mathematics, not just for me to just have everything written down and say, okay, this is integral for this and that. No, I want us to make the mistakes together and solve everything together, so you can see that there's a process to solving this. Okay, so now you would have, say, so we have simplified all of this integral, which looks complicated, to something like this at the bottom here. Now, of course, you could take u to be sine of x. Okay, in this part, you take it to be sine of x, and you would integrate. It's very simple and elementary, but for this part here, I will just go down the results because it's not all the hard work has been done. Nothing serious is going to happen again. We have essentially solved this problem. So what if you integrate this, you would end up with, say, square root of 2, then square root of 2, and then you will have a pi all divided by square root of 2 times square root of 1 plus t squared, okay, times square root of 1 plus t squared, then plus square root of 2. Now we have done this integral before. Yeah, if you missed it, please check my channel. We have solved it before, so don't need to go ahead and solving it here. Okay, solved in this channel before. So now I would now we are going to this. Now our problem now would be reduced to finding the integral from 0 to 1 plus the integral from 0 to 3 of what? Of pi divided by what? Square root of 2 and square root of 1 plus t squared times the square root of what? 1 plus t squared plus what? Square root of 2 dt. So now we're going to integrate, say, integral from 0 to, let's say, 1 of square root of 1 plus t squared times square root. These are simple integrals you can do with in tangent substitutions. Also, I have already solved them on this channel before, so you just need to just search. The videos will be in the description in the comment below, but essentially we have solved all the difficult problems, and it remains for us to just compile our result. Now this integral, this is equals to first of all, this is equals to, I have the results here with me. So you have a logarithm pi over square root 2 times the logarithm of what? Square root of 2t plus square root of 1 plus t squared, all divided by what? T plus 1. Okay, and we're taking the result from 0 to 1, and then also from 0 to 3 plus everything here, then from 0 to 3. Okay, so if when all is said and done, you would have, this is pi over square root of 2 times the logarithm of square root of 2 plus pi over square root of 2 times the logarithm of what? 3 square root 2 plus square root of 10, all divided by 4, and then minus 3 pi 2. This is the part we neglected. That part I asked you to do 2 pi log square root of 2 times the logarithm of 1 plus square root of 3, all divided by square root of 2. And if you simplify all of this, you will get your final result. So let's do a brief recap of all that we did towards this solving this integral. So first off, we started with this integral to solve. Okay, wait. I think this was the first video I tried to make. Well, okay, so first of all, we started with this integral to solve, and then no, not this was not the first. This was the first one I was trying to make. Then I made a mistake and then tried to remake it again. Yeah. Okay, this was the video. Yeah, so this was the integral we wanted to solve before, and we said we start with the argument whereby we let it to be equal to theta of x. We simplify the whole thing out, and then we ended up with something nice, and then we turned all of this into a double integral, and then that was how the problem was solved. So I really appreciate your time following. If you follow this video to the end, congratulations to you. Okay, I'll be making more and more videos obviously on this one. Maybe I would, of course, the more I make videos, the more I will improve on the video because it's not so easy here. Okay, yeah. So thank you very much, and please have a nice day. Bye.